In this video, we are going to solve the following system of linear equation using the inverse of coefficient matrix. So when the question asks you to use inverse of coefficient matrix, it means that you need to solve the system using the equation x equals to A inverse multiply with B. So this is known as the inverse method, or sometimes it's called the inversion method. So either way, when we want to use the inverse method, we first need to find the inverse of the coefficient matrix. Alright, so first and foremost, to start with the calculation, we first write the system of equation in a form of Ax equals to B. So we have to identify the coefficient matrix A, the column vector of variables x, and the column vector of variable B. Sorry, the constant B. So in this case, we write the coefficient of x, y, and z. We have 1, negative 1, 2, negative 5, 7, negative 11, negative 2, 3, negative 5. And we have the column vector of the variables x, y, z. And we have the column vector of constants negative 1, 8, and 4. Okay, so now we have written the equation in x equals to b, Ax equals to b form, equation form. So next we need to find the inverse of A. Alright, so in this module, we focus on finding A inverse using elementary row operation. That is, we write A in its augmented matrix. We write A next to the identity matrix, and we use elementary row operations until we have the identity matrix, and the one that obtained by using the same ERO is the inverse matrix of A. Alright, so we are going to reduce A and the identity matrix so that we can find the inverse of A. So first we write A, 1, negative 1, 2, negative 5, 7, negative 11, negative 2, 3, negative 5, and we write the identity matrix. Okay, so let me scale that down. Okay, so first we reduce, since the first entry is already in its pivot position here. So that means that we need to reduce row 2 and row 3. So we take row 2 and add to 5 times row 1. Apply that to row 2. So we have 0, 2, negative 1, 5, 1, 0. So make sure you are very careful with adding or subtracting numbers, especially when you have 0 plus, in this case 5 times row 1. So 0 times a number, you will definitely get a number with it, not a 0. Alright, so row 3, we add with 2 row 1, apply that to row 3. So we have 0, 1, negative 1, 2, 0, 1. And then we copy, just copy row 1. Okay, so next we interchange row 2 and row 3. We have 0, 1, negative 1, sorry, 2, 0, 1, 0, 2, negative 1, 5, 1, 0, 1, negative 1, 2, 1, 0, 0. Okay, so next since this is already in its pivot position, so we need to change, we need to reduce row 1 and row 3 so that the entry above the pivot position should be 0 and below the pivot position will be 0. So we take row 1, add with row 2, apply that to row 2. So I'm going to write it here. So we have 1, 0, 1, 3, 0, 1. Next we reduce row 3. So we take row 3 minus 2, row 2, apply that to row 3. So we have 0, 0, 1, 1, 1, negative 2. And we just copy row 2. Okay, so since the third row already contains a leading 1, which is in the pivot position, so we need to reduce row 1 and row 2. So we take row 1 minus row 3, apply that to row 1. I'm going to take it up there. So we have 0, 1, 0, 0, 2, negative 1, 3. And next we have row 2, add row 3, apply that to row 2, we have 0, 1, 0, 3, 1, negative 1, and we just copy row 3. And so there you have it. We have reduced A and the identity, applying ERO to obtain A inverse. So this is in the form of the identity matrix with its A inverse. So we know that this matrix here is our inverse matrix. So we are not done because we only obtain the A inverse, but we have not solved the system of equation. So going back to the question, to solve for x means that we need to solve x equals to A inverse B. So from what we have previously written, we have x x, y, z. And to solve for x, y, z means we need to multiply the inverse. In this case, we have 2, negative 1, 3, 3, 1, negative 1, 1, 1, negative 2. And we multiply that with the column vector of b, negative 1, 8, 4. Okay, so gonna a bit. So we multiply the row, going to change it with yellow, row 1 with column 1, and we repeat the process for row 2 times column 1 and row 3 times column 1. So we have 2 times negative 1 minus 1 times 8 plus 3 times 4. And we do the same thing for the second row. We have 3 times negative 1 plus 1 times 8 minus 1 times 4. And lastly, you have 1 multiplied with negative 1 plus 1 times 8 minus 2 times 4. So we solve this matrix, we will have the solution for x, y, and z. So you have negative 2 minus 8, that will be negative 10, plus 12, you have 2. The next one, you have negative 3 plus 8, that will be 5. 5 minus 4, you have 1. And lastly, you have negative 1 plus 8, that will be negative 7. Positive 7 minus 8, we have negative 1. And so there you have it. We have the solution for x, y, and z. Okay, so specifically in this example, we show how to use the inversion method. So in the next lesson, you are going to look at different ways of finding the inverse matrix of A. So in this video, we only look at the method of finding A inverse or the inverse of A using elementary row operation. So we have many other methods that you need to look out for. So that's it for this example. Bye.